This was actually a fairly good year for this project, so I'm very pleased to tell you about this. The basic idea, let me see if I get that right, is the bottom line of this article from AT&L magazine, where they're talking about the C-17 sustainment organization at Warner Robins. And if you look right down there at the next to last line in boldface, that's my boldface, not theirs. They said, organic infrastructure sustainment is how you keep the C-17 alive and inexpensive to operate. We needed to extend that concept to software because airplanes aren't just hardware anymore. So the idea here is the sustainment problem is a dynamic one. The number one factor here is the famous color of money problem. The famous color of money problem for people who aren't from DoD is different organizations are responsible for funding depending on whether you're doing maintenance, logistics, enhancement, or new development. And so you get this business about, well, who's going to pay? That really is the main thing that's going on in this dynamic idea. The effect when this problem about who's going to pay occurs ought to be obvious. It's delay, 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 delay. And everybody who's been involved in sustainment has faced this at one time or another. When we get that delay effect, funding can sometimes come years later. If there's a POM cycle that gets in the way, you know the POM cycle is 2 years approximately, 3 years sometimes. And so if you miss the first decision point, you got this long, long wait. What we wanted to do was to provide some evidence of what the effect of that delay was so that you could encourage the decision makers when they needed to make a decision more quickly. We came up with this basic picture of how sustainment works. And if you'll start with the upper left-hand corner there, it talks about I operate the mission. So I go out and I fly a mission and I get an after-action report. And the after-action report generates some performance data and also generates some requests that go up the ladder to Mission Command and JROC and other decision makers about what you're going to do in the future. And they determine if there's a needed upgrade. And they'll put that in the queue of what are needed upgrades. If they determine that there's a queue for needed upgrades, that will get passed along to the sustainment organization, which is the third bubble, and not the sustainment organization, the program management office and the sustainment organization both might determine this. So you can view that as the program management office. And then there are two kinds of funding coming out of that. One of the funds says, okay, put these enhancements in and go straight across. I don't need any extra funds, it's already in the budget. The other one says, nope, I need more money, and I'm going to update your infrastructure for doing the sustainment. And if I update the infrastructure, which is the bottom one down there, both those paths feed into the actual work of doing the sustainment, and then I deliver an updated piece of software. One of the questions you should ask yourself is, what's infrastructure for software? It's actually analogous to the infrastructure for hardware. It's the tooling and the processes whereby we do things, and so you're looking at the end result being this, how effective are the sustainers themselves? That's what you do when you change the infrastructure for the how you're doing the mechanics. You change the process and the people, you update them, and then you get better sustainment. So this was the fundamental idea, was this picture. And in this picture, you'll see I have 3 gaps listed. The first gap is the mission capability gap, which is the result of the difference between how well I did and what I wanted to do. The next one is the sustainment funding gap. It's how much money do I need and how long it takes to get it. And the third one is the sustainment performance gap, what the operator wants from the sustainment organization versus what the sustainer is delivering. And you will have copies of these slides. What you'll see then is we're looking at the gaps are 3 different things. They're the performance versus the goals provides a gap. And those are forcing functions on how we do sustainment. We turned this picture into a VenSim diagram. VenSim is this product from Ventana Systems, which is a stock and flow model of a simulation. So it's a continuous simulation. And you'll notice I have a little tiny control dashboard up there. The control dashboard is in fact about 16 different controls that you can use. And then each one of these, I'm going to blow one of them up, says that as a subset of the model, that there are supplies, there are people, there are funds, there are different supplies, those are the stocks, and then the flows are valves that control that flow. This is really fairly easy to do a sustainment model like this, or to do any model like this, but it does take some practice. If I can go backwards, yes I can. The same blocks that you had, the same bubbles that you had on the first diagram are replicated here in one form or another with several loops of how it behaves. So one of the loops of how it behaves is a demand loop right here, which says if I'm doing a really good job of flying the mission, there's more demand for the mission. Think B-2 in Iraq 2, right? We knocked out their whole air defense system in 2 nights. So if I do well, then there's a demand to update the mission and do more work. If there's not doing so well, then or if I do well and I need more enhancements, I go through a different part of the loop. And if I can't meet the demand for the enhancements, then it generates disagreement. And so I can actually get to a kind of a tipping point in this organization where if the demand can't meet the supply after a while, I go look elsewhere for the, okay? So we have to be careful to do sustainment well. Now, there's a set of steps in using this model. The big deal is calibrating it to the organization. You can imagine with all of those stocks and flows, you need to get numbers in all of those things in order to say it represents the real world. And the key to making this kind of simulation work is you want to kind of get to a stable point where if you were doing well, everything looks approximately the way the organization is working. And then you want to hit it with a stimulus, for example, sequestration. Yeah, and you want to see if the model behaves the same way sequestration actually happened. So you're doing 2 things. You get a stable system, you say, look, it looks just like the system as it is, and you do a couple of scenarios to say, does it behave the way the system actually behaves? And sure enough, it did. But let me give you a couple of examples of what kind of calibration we needed to do. The critical ones were these 4. The available staff, the staff in technical training, the requested staff, I guess there's 5 of them here, the committed stakeholders, and the available investment funds. Now, none of these might be exactly what you thought they were. They are designed to make the system work. So the available investment funds being $125,000 is like an hourly rate at which we consume the money, okay? And then we derive some variables and go back and check the system. So we derived some variables and said, well, these are things we might be able to go check to see if they're balanced. Go back and check all these, and sure enough, these numbers match with what our customer said the system actually looks like. And there are a bunch of them there. Mission capabilities requested. That'll give you an idea of how calibration is difficult, because the definition of what mission capabilities requested is actually the detailed specification. And so we took a while to get that. Let me do a scenario for you. The performance under increased threat was one of the ones that was an interesting scenario. So the context is that the system's currently operational, there's a stimulus, there's a new threat, maybe a radar can detect the B-2. There's a response that says upgrade is requested and funded without funding the infrastructure. And what happens? They reduce training to keep up with the demand. And what's the outcome? What we'd like to do is say that the sustainers work harder, but eventually the performance declines. And what does it look like? This one probably needs to be studied a little bit. In the upper left, there's the sustainment performance overall over a whole 5-year period. But if you look real close, you shrink the y-axis scale a whole lot, you'll notice that the work harder generates a short-term improvement, which is this second one. It's very short-term. It's only about 2 months. And then after that, your sustainment performance falls off if you don't fund the infrastructure. If, on the other hand, you train more and you fund the infrastructure, you get longer-term performance and you get the higher level curve there. So that even if I have the same budget, but I switch some of the budget into this in increasing the infrastructure, I actually get better longer-term performance and I can survive longer. That's not intuitively obvious. And so this is a good example. This is a picture of what the equilibrium looks like at the top level and how fast you can fall off depending on what happens if you quit there. So let me give you some results. Calibration was easier than we thought it was going to be. It took about 7 months, but only about 30 to 40 days worth of effort to actually do the calibration. And we should be able to do it faster than that, but remember we're talking to people who are volunteers when we were doing this. They weren't committed to our work. The scenario analysis does show what we expected, and we have 4 distinct scenarios in a large 60-page paper that you can read. And the customer has actually purchased the VenSim tool, has asked us to come back and help us with one more sustainment organization at their location. And we're just really tickled that we got this extension like that from the customer, because they're putting their own money in the pot now, not just research money. Thank you.